Richard, we're glad you're here. Richard Mattheosian.
Hi, well, thank you all. I'm going to sit down. For various reasons, I'm going to sit down. So I'd like to thank Tom Johnson, our chapter's manager of programs, for inviting me. Tom, of course, is a famous blogger in his own right, so it was a real honor to be invited. I'm going to give a presentation here that's designed for interaction. That is to say, if I zip through these slides, I'm doing wheelies with my slideshow here. It'll take about 15 minutes, so if you sit on your hands and keep your mouth shut, we'll have a very short meeting. All right, so I'm
So if that's what you want,
So, and the reason for that is that the topic we're talking about here has so many different variations and side things and ways to go that you'll all have had different experiences, and if you share them, it'll be a lot more fun. So many of the slides end with a little thing on the bottom that says share your experience, like that, only smaller and at the bottom. So let me say a bit about me. That's me with my old friend there. I write for an audience of developers, and I understand that audience because of my background. As Dave told you, I started out as a mathematician. I got my PhD from UC Berkeley. My thesis, by the way, is entitled Simple Algebras and Relative Galois Cohomology. And I promise you I don't remember what that means. But, whoops. The PowerPoint is tricky here. There are two windows up here, and if I try to scroll the one on the right, I have to be sure I'm there, or I get the one on the left instead. So I had a dispute with my first thesis advisor, and so while I was still a graduate student in math, I had to go out and get a full-time job as a programmer, which in Berkeley was fun. I made clinical laboratory computer systems on tiny computer, PDP-8s. They were 4K 12-bit words were the main memory, and when we got really advanced, we had a 0.5 megabyte disk, and that's what we used for swapping and time sharing and so forth. So we developed some fairly sophisticated systems in the 60s on those tiny machines. But anyway, I spent about 15 years as a developer and development manager, and then I wrote a couple of computer books, one on the Z8000 microprocessor. I don't know if anybody's ever heard of that. It was supposed to be a 16-bit follow-on to the Z80, which was the basis of all the CPM machines that were so big in the 70s. And the second one I was on, it was called Inside Basic Games, and it was about how you program games in BASIC on different versions of Microsoft BASIC, basically, on the Apple II, the TRS-80, and the Commodore PET. So that was fun. Anyway, then writing a book about the Z8000, somehow I wound up in the semiconductor industry as a technical marketer for about 10 years and did some strategic marketing. I worked for National, I worked for Zilog, I worked for Hitachi America here in Brisbane. Anyway, so I got tired of all that, and I decided I'd do something, that used all of my skills, so I became a technical writer. And since the early 90s, I've called myself a technical writer. That's what I've been. And I've been kind of immersed in this culture of technical writing, so I kind of understand what writers are trying to do and why they're having trouble doing it. So there you go. That's me. Now this this is a highly simplified view of the parallels between what writers do and developers do. And on the left here we have word people, that's us, and on the right we have the code people. And maybe initially when you're on some project, some marketer or executive or somebody may have laid down the initial vision for it and so forth, but when it comes to building something, it's the developers who do it. And what we do as writers is similar enough. If you see those two horizontal lines there and that tiny print that says iterate indefinitely between the lines, that's essentially what we spend our time doing. We write something, we build it, we get reviews of it, same as what the software developers do, really. And so the idea is, since we have to work with the developers, where did my cursor go? Oh, there it is. If we use these tools that the developers use, if we try to leverage those tools, it will help us reduce that semantic gap or impedance mismatch or whatever you want to call it between what writers do and programmers do. And the more we get so that we and the developers understand each other, the easier it is for us to do what we have to do. So to the extent possible, we have to function as members of the development team, and that starts with becoming comfortable in this environment, in the environment that the team is working in, that the developers are working in, and so forth. So, if you remember the picture I just showed you, at the top of it were repositories, and maybe it'll be different someday, but right now files are at the heart of everything we do. We just have lots and lots of files, and that's what version control system repositories are for. They help you control your files. Developers store their source code in files, and we store our text and images in files. And we have a whole slew of files to keep track of, and when we try to support separate versions of things, it multiplies and it gets more complicated, and it's harder to keep track of. And so version control systems, that's what version control systems are for. Git, Subversion, Perforce, they're version control systems. There are many others. That's what they're for. They're to help you keep track of your files. So every version control system provides some kind of set of basic operations, like you check things in, check them out, stuff like that. You want to keep you keep local versions, you modify them, you work with them, and some of them integrate with tools like an XML editor, for example. You might have stuff in Perforce, and you may be using XMetal to edit files, and it may be that you can check files in and out directly from XMetal, say. And most of these version control systems have integrations with popular tools, whether they're integrated development environments or editing tools or whatever. So we've developed these techniques with topic-based authoring and so forth that involve having large numbers of small files. that we can mix and match and maybe do single sourcing from put this bunch together for that output, this bunch together for that output, this bunch together to do a help system, and so forth. And we really need help keeping track of all those little files. And usually what we really need is a metadata-based way of keeping track of them. And version control systems don't really provide that. So if things get too big, you need component content management. But the version control systems, if you can't afford component content management systems, the version control systems do help keep the...
Could you go into just a little bit of what the difference is between a component system and a version control system?
Okay. Component content management basically understands the pieces that are in that repository, whereas a version control system has no concept of what's in there.
It just knows it's a file.
It just knows it's a file, whereas the component content management systems understand the metadata that you've associated with those files, and they can use that metadata to help you do whatever you need to do. Keep track of what goes together and so forth.
Can you name some products, some CCM products?
I can't right off the top of my head.
SDL.
SDL, yeah, SDL, right, that's a good one. What's that?
SDL Son.
Uh-huh. Any others?
Authorite T.
Yeah, I guess that is. Yeah.
That's proprietary.
I don't think what?
Backline?
I guess so. I don't. I've never actually worked with a component content management system. I did work for Documentum at one time, and we sort of did some of that, but it was 10 years ago before that technology really got integrated with the idea of topic-based authoring.
Richard, I have another question. So, do you have any ideas how a version control system like it, you could update it with metadata to do, more enhanced kind of component management?
That's a good question, and I don't know the answer other than maybe if you keep a separate spreadsheet or something of all of your files and what and the metadata associated with them. You could use that to keep track of where you need to look inside your version control system. But to get the version control system to do it, you'd really have to, it would have to be configurable, programmable, and so forth. And I don't know the extent to which any of them is that way. So the general idea with all repositories is that they keep a master copy, and you have a local copy, and you want your local copy to stay in sync with the master. But you don't want your work to mess up the master irretrievably if you've made some mistakes, or you screwed something up, or you accidentally deleted something, or whatever. So that's what the version control system does for you. If you commit something that's not right, you can generally back it out, because the version control system keeps not only your current one, but your last one, and the one before that, and the one before that, and so forth. That's what they're for. And committing a change is like a formal process. So the version control system keeps information that you give it when you commit the thing, and it keeps information that it needs to keep track of all of your different versions, and to keep some documentation of what you changed and why you changed the committed files and so forth, so that your fellow project members can go back and look and say, what happened in that last commit, or 2 commits back, or 7 commits back? What actually changed? And that can be really handy, and that's just maintaining your own file system. You'll never get there. So that's why you have a version control system. Now, in some development environments, when you commit something, you have a lot more complicated process. You might have to pass some unit tests on your code or something like that. Maybe you have to actually do a build and then run system tests before your commit is actually accepted. But most writers don't have to do that. If you're working with JavaDoc, for example, where you're in the code, then you might run into something like that, where you're actually you can feel the peer disapproval when you break the build, which of course none of us has ever done, and we invite you to share your experience about that. Have any of you ever had an opportunity to work in the code? Yeah. Okay.
I've broken the build.
You've broken the build? Yeah. So have I. Yeah. You're giving us a bad name. So, and have any of you been in the situation where you're basically not allowed in the code at all? No? Yeah, so? Is that, how have you been able to deal with that?
It's been tough.
What's that, stuff?
I said it's been tough.
Yeah. Okay. Anybody, no war stories about? On we go. So merging. Merging is putting your changes into a changed master copy. That's essentially it. If different people work on the same file, then they might interfere with each other's work, right? You're changing, they're changing. And one way to prevent this is to allow only one person at a time to work on a file. That's called pessimistic locking, and what happens is you declare to the version control system, I'm checking this out to edit it, and it says, okay, nobody else can check this out for edit. They can look at it, they won't see your changes, but they can look at it, they can use it in a build, they can do whatever they want, except they can't change it. So that turns out to be inefficient. Often somebody wants to make a quick change to some file, and often when you check out a file, you may check out a few and forget about it, or spend a lot of time looking at different things, and it's really not efficient.
Is this like when you go to the library in school and you find out a college professor has checked out all the books, and then they've been sitting on his desk for 3 years?
Yeah, it's like
coming back. That kind of thing.
Yeah, it's kind of like that kind of thing. Okay, so that's pessimistic locking. So it turns out that most changes in text files don't conflict. Okay, so if so John checks out a file, and then Mary checks it out, and she makes some modifications and checks it back in, and meanwhile John's been thinking about it, and finally he makes his changes and goes to check them in, and that's where the merging comes in, because the version control system detects that you're trying to check in changes, but the current version is different from the one that you checked out. So there's where your merging comes in. It has tools to compare these things, and in many cases it just says, okay, those things don't overlap. I mean, it doesn't do an analysis of the content of your stuff, and it's possible that you made changes or they made changes that actually will conflict somehow, but if they don't conflict at the text level, then you can both make them, and the system will just take them in without complaining. But if there is some sort of overlap, every version control system has a way to handle those. Usually they'll show you they'll show you the two versions and say, okay, John, there's what Mary did. Here's what you're trying to check in. Give me something for that line that's right, okay? I can't take both versions. Give me one version, and you have to look at Mary's, and you have to look at yours, and you have to say, okay, I can see what she was trying to do. I can see what I was trying to do. Boom, and so you make some change. So the workflow. Here's John's workflow. He when he gets to step 3, the VCS has noticed that his conflict with Mary's, or they don't. And if this don't conflict with Mary's, poof, you're done. And if it sees a conflict, then you have to fix it. It's a pretty simple workflow. And I don't know, is there anyone here who's actually worked in this kind of situation? What are your experiences?
Miserable.
I,
Well, we have Perforce, and the thing is that you get 3 different documents with Perforce, and none of us are quite sure why, because there are only 2 people working on the file. But it has like, this is like source, and there's like upstream and downstream. I can't remember what it was, but it's very confusing. And there are many stories about how, some people's, that whole day's work got lost because somebody didn't merge it correctly. But if the system doesn't know what to do, then, that's the warning that everybody tries to avoid, because then you've got to look line by line and say, well, they did this, they did that, but which one's right? And, well, the person that did that is gone already. And so, there's been a few times when I, waited a couple days to check in a specific file because I wasn't sure what the other person was doing. And, sometimes they're just little like one word difference. Sometimes it's a value that's different. And so, it can be a major hassle. And then one time I had 3 people looking at this, and each one of them disagreed, and they said, well, whatever you think is best. And I said, that sounds nice, but when I do it, you won't like it.
So that sounds miserable. Has anyone worked in a pessimistic locking system? Yeah? How did that work out?
well, I think given the volume that we're doing, it's something we have to do kind of to inflict our workflow, so to speak. We're trying to induce some quality into internal documentation. So it's almost like a process enforcement for a development cycle. It's kind of a cross between hardware and software. It's kind of interesting.
Well, do you find that it's inconvenient for people who are trying to work on the same file, or don't you have that situation?
No, I don't think so. I think it's the nature of how we structure the content, so it's workable.
Mhm.
The way we manage our workflow is, the technical people have touching in the writing cycle is very tight, very good turnaround.
Oh, good. Anybody else?
Yeah, I've worked at a place with pessimistic locking, but one thing is a lot of our files were binary, not
Oh,
text.
yes.
So that's a big, you can't merge those.
No.
And it was a large company, so one thing to make the situation a little bit better would be that big companies, so the overhead of having a script run to tell everybody who'd had a file checked out for more than X number of days, we get an email about it, so that we wouldn't just
So we're making
kind of,
it
oh, it's
clean.
been so long ago that I forgot that I had that thing checked out. So that was, I'd say if you've got, a large group, you might think about that kind of overhead of having your tools person do
Yeah.
that. And also, we would have an issue of people taking files from the server and putting it on a local workspace. So if people forgot to refresh their workspace, then there would be a possibility of 2 people somehow or another getting more than 2 versions of a file.
Yeah, yeah.
Okay.
Those are all things, and so binary files, pictures, of course, are generally binary files, but also there's kind of semi-binary files like FrameMaker files, Word files. They're text-based, but there's so much extra junk in there that it's really impossible for a version control system to see what's different. I think some of these products have their own diffing tools, comparison tools, but for a version control system to do it for you, that's harder. So in those cases, yeah, you basically have to use pessimistic locking. Just check it out, work on it, check it in, and
Yeah, see if you can get a lock when you check it out. I
Yeah.
mean, it's frustrating, but it's not nearly as frustrating as having spent a day on something and not finding it.
oh yeah.
File.
Well, yeah, if you're checking it out, thinking that you're working on it exclusively, and the system's using optimistic locking, and somebody else goes in, that's not good.
Yeah, that's just this optimistic thing of having two people working on a file at the same time just seems really dangerous to me. I can, because it seems to me that I can see a system where, if I changed one word and another guy changed the same word, the system could catch that. But I can easily see a guy changing something in some part of a paragraph and somebody changing something in another part of the paragraph in a way that doesn't look like a conflict.
Yeah.
Except it's made cottage cheese out of
Yeah.
logic or something or other. And it
Yeah.
seems to me, everything's going to have to be read again by
Yeah.
a human or something
Yeah.
who's awake.
Yeah, that's the thing.
With Confluence,
It wasn't a big disaster.
It's a big problem no matter how you try to solve it. If you have multiple people working on the same thing, I guess you need communication, but
Like Google Doc, which does it all live.
yeah, Google Doc is good for that.
It does what you need to do.
Yeah. Yeah, I think basically with Google Doc, you can see what everybody else is doing while they're doing it, right?
It's shared.
Yeah. Yeah. Yeah, I haven't. I worked in a situation like that once, but not very often. But yeah, that's scary. I mean, you're sitting there typing and then something else is at the same time.
Your documents slipping away.
But you're seeing who's doing it. It's showing you who's doing it.
Yeah.
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 How dare you delete that sentence I was reading?
Unless you're using a department password now,
Uh-huh.
you're like, wait a minute, that person is supposed to be on their honeymoon in Hawaii.
Yo.
Why are they, making a change?
Honeymoons can get draggy. All right. Anybody else? Shall we move on? All right. So repositories are either central or distributed. They're basically two kinds, and essentially all the well-known ones except Git are central, and that means you have to be connected to the repository's server to do anything, to check things in, check things out, whatever. And Git, on the other hand, is modeled on something called BitKeeper that they were for a while using for Linux, the Linux kernel code. And, Linus Torvalds wasn't that happy with it, so he developed his own called Git, or he designed and supervised the development, or however you want to put it. He says it only took him 10 minutes, and it looks like it in some ways. But anyway, the distributed aspect of it basically allows for easy backup, because you have distributed means you have whole copies of the thing everywhere. and it avoids the politics of who can write to the master. People have their own copy, they can do what they want with it, and then when they're done futzing around, they negotiate about merging the changes into the main line later. And Torvald says he does merges all the time, and so he wanted merges to be fast. And that's how he designed it. Basically, if you go to, say, GitHub or someplace like that where there are lots of Git projects, and you want to play with one, you can clone it from that repository, and Git has a sort of built-in keyword origin. The place you cloned it from it refers to as origin all the time, but you can have other remotes as well that you deal with. But basically, you have a relationship with origin where you've got a complete copy of origin as of the time you did it, and by complete copy I mean all of the code, all of the branches, all of the history, everything is on your machine, sitting right there in your little Git directory for that project. And you can have a dozen projects on your machine, and each has a little Git directory that has the complete history. And of course, you need a certain amount of memory to make that work, but it's not that big, generally speaking. Well, I don't know how big it is for the Linux kernel. I haven't tried cloning that repo. The Git conceptual model and its basic entities are not that easy to understand, so it's kind of like Word. You know, you figure out how to do what you want to do with it, and the other 98% of it you kind of ignore or try to avoid, or at least hope it doesn't wreck you.
What an improvement over the
So anyway, GitHub is a website that supports Git projects, and many open source projects use it. So if you're looking for a chance to get involved in some development project or other, you can find them on GitHub be happy to have people come and help with documentation or whatever, or develop new code if that's what you feel like branching out into. Why not?
I'm
Yeah.
in the process of reviewing a book on programming for Microsoft, and they've stored all their stuff on, because it's got a lot of coded samples and stuff. They're using Git to download this, go download the stuff and run their samples.
Yeah, yeah. It's basically a new paradigm that it's just changed a lot of stuff, especially in the open source world. Let me go here. So the thing that makes Git special, in my opinion, is the easy branching. Just imagine how many different projects contribute to the Linux kernel, right? I mean, if you don't have an easy way to start and carry out and integrate those projects, you're kind of bogged down. So that's basically why that's why Linus designed Git to have low overhead branching. Basically, everything in Git, every branch in Git is just a pointer to some stuff. Everything in Git is all there, and a branch is a set of pointers. And you start a new branch, some of the pointers are different. It just takes moments to say, you create a branch, it looks just like the other one, you start diverging, that's fine, your pointers are different from those pointers. And so when you make a new branch, it doesn't take very long, and then you can do what you please in your branch. You can check things in. You could be on the beach, unconnected from the internet, sitting on your own machine, in a fallout shelter, wherever, and no connection to the outside world. But you've got a complete Git repository there, and you can check things into it and check things out and do all of the operations that you would do with a central server, but just on your own machine. And when you're done and you've done your development, you've written your changes, whatever it is you're doing, and you've checked them in and tried them and done everything on this branch, and it's the way you want it, you ask for a pull operation. You issue a pull request. And pull requests are basically Git's review process. So you've created a branch and you develop independently, and then you say, okay, please pull my branch into the master. And what that does is it generates this whole workflow. Let me go back for a second here and see if I... It generates this whole workflow where you create a branch and you make a copy of it on origin, the place where you got your thing, so that other people who are working on the same project can look at your branch when you want them to. They can look at it when you don't want them to, but anyway, they can look at it. So you make and test your changes in your branch locally. You keep it in sync with origin, and you can, at the same time, when you're making your changes in your branch, you're free to pull in every change that happens to the master. You can pull that into your branch, so that your branch is essentially just like the master and stays up with the master except for the part that you're changing. And so when you got it where you like it, you issue the pull request, and that draws everyone's attention to it. Everybody says, oh, let me go look at that branch. And because it's it's the whole thing. A branch looks just like the master. It's just a different branch. It's all the stuff they can build. Suppose your project is like a static website built out of Markdown files or something, and generated with a static website generator. Well, they can go to your branch, run it locally, run the website generator locally. It just takes a few moments. They can look at the website that gets generated, look at your changes in that context. They don't have to guess how things are going to fit in by looking at just a piece of code. They actually see the whole thing if they want to see it. And so they may make comments, and GitHub supports this, by the way. If your project's hosted on GitHub, then you can have your interactions on GitHub. So you can GitHub will send you an email when somebody comments on your pull request, and they may say this, that, the other thing, and then you may say, oh yeah, this, that, and the other thing, and you'll go back and forth about it. They may not like this part, or they may like this part, and you keep going back and forth until everybody says looks good to me, okay? And then somebody merges the branch into the master. Maybe it's you. It depends on how your permissions are set up on GitHub and so forth. Maybe you just merge it into the master. Maybe some other authorized person merges it into master. However you want to set it up, and then you just delete your branch. Yeah, you were looking at me like you had a question. I remember that Linus Torvalds didn't like BitKeeper. That's why he developed his own. I've never used BitKeeper. Yeah. Well, the truth is that in Git nothing is deleted. Nothing ever goes away.
Oh, okay.
Yeah, in fact, it's almost impossible to make anything go away in Git. It's just designed to be.
In other words, what you're suggesting is you could delete it off your local machine because Git still got it.
No, you delete it from the Git repository. Nobody sees it, but it's still there if you had to. First of all, everything, it's just a set of pointers.
Okay.
So you're not deleting anything. But
Go back into history and reconstruct.
yeah. What's that?
You could go back into history and reconstruct.
I believe that's the case. Out of the history, you can reconstruct the branch, and Git keeps a complete history of things. And I'm like up to here if you're asking me questions about Git internals, okay? But it basically Git doesn't ever lose anything. And anybody else have things to share here? Anybody else worked with Git? Yeah, Andrew.
I've heard people kind of pat themselves on the back for becoming submitters. Can you talk about the status of a submitter and what
That was or committers, I think you mean. That was a big deal, certainly, and may still be a big deal with the Linux kernel. Basically, Linus Torvalds rules everything, but he needs to delegate a little bit because he's only one person, and the Linux kernel is huge. So certain people are knighted as committers, and they can commit things to the Linux kernel. Now, I don't know how that has changed with Git. I mean, when Git is only 10 years old, and that's when he did it. And before that, that was when they were using other source code control things, being the committer was a big deal. And it may still be a big deal. I mean, with Git, you still at certain points have to accept something and merge it. So not everybody can do that. If you have some change that you want to make to Linux, the Linux kernel, you can develop it on your own. You can go clone the Linux kernel, Git project, and work on it all you please. And then if you submit a pull request, they may accept it, but probably they may not have the time to look at it, or think enough of you or know enough about you to actually consider it. So there you have it. Well, that goes without saying if you're dealing with Linus Torvalds. He runs a famous mailing list on which he insults everybody who asks questions. Yeah.
So I recently do this a lot.
So the next time, see, the workflow is you clone the repository, you make a branch, you mirror the branch on the origin, and then he can pull your changes out of the branch. But what you do is keep the branch as close as possible to the master, except for the thing you're working on or the things you're working on. And you can make if you've got really separate changes, you can make 4 branches or whatever, and each one dedicate to one of those changes. And so you can put a pull request on this branch, and that's for such and such small change, and he can look at it and do it, or everybody can look at it and do it. You don't need to have just one branch for all your changes. So that's one way of doing it. Nobody curates it, right? Yeah, that's the problem with wikis. You need somebody who goes through, organizes it, throws out old stuff, builds indexes, whatever it is. You need somebody who owns it and is responsible for its architecture, because the architecture of a wiki is like the Winchester Mystery House. All right. So, anybody else? Did what? No. Here's an aside that Tom asked me to put in here. DITA for small teams, or small impecunious teams. If you're on a DITA-based project, there are a lot of ways to go, but some of them are pretty pricey. And Elliot Kimber is the author of DITA for Practitioners. It's actually called DITA for Practitioners Volume 1, but that was like 5 years ago, and he hasn't started Volume 2 yet, and now he says he's going to come out with the second edition of Volume 1 before he starts Volume 2. So I've dropped the Volume 1 designation there. But Elliot Kimber, very interesting fellow, and he's on the all of the central committees of DITA, but those are big committees, so his voice is not the only one there. But anyway, he has started this separate small project. There's some links at the bottom here to DITA for small teams, and his tool set, his central tool set is Git for managing the content, the DITA Open Toolkit for generating the output, Jenkins for automatic processing, and Oxygen XML for editing and producing stuff output locally. Now, some of you may remember back from the 60s, I guess it was, there was maybe it was the 70s, the British series Upstairs, Downstairs, featuring the famous butler Hudson. So Hudson gave his name to a project for automating builds and things like that, and it was a Java-based project, and anyway, it turns out at a certain point, Larry Ellison bought the Bellamy Mansion, and Hudson stayed on as his butler, and so the other people who left hired Jenkins. Or to put it in more technical terms, back in 2010, when Oracle decided to trademark the term Hudson, the rest of the project forked off into a new project called Jenkins, and otherwise I don't know. I mean, they've diverged since then, I suspect, but I don't know the extent of the divergence. But anyway, Jenkins is what you have to do now if you want if you want to automate your build processes and so forth. And Jenkins is also free. So the DITA Open Toolkit is free, Git is free, Jenkins is free. Oxygen, the only part that isn't free is Oxygen XML, which is really quite highly regarded. And we had George Bina here, was it, last October 2014, talking about it. So if you were here, you heard about it. I thought it was a very impressive tool. But I've never actually had to use it.
I've used it a lot. It's a really good tool.
Is it? Okay. Anybody? Anybody? Yeah. And it's on GitHub. You can clone your own copy of it and play with it. But as you say, it isn't that far along. All right. Anybody else? Anybody else here use DITA? How many people use DITA? Not that many, but enough.
Let me just.
Okay. Anybody else? Okay. These links at the bottom, they take you. The first couple take you to Kimber's project and his that rant there, Blogspot. That's his posting about data for small teams. The others are just documentation for the products there. And anyway, I don't know how we're. Is this? Are we going to make this available on the website?
Yeah, we'll put it on the STC.
So all of these links, you can download the PowerPoint file, and you can give this talk yourself. Feel free. You have my permission. So now, issue trackers. Software is complex. Our docs are complex. And the software and the docs interact in many ways. And an issue tracking system keeps track of all the issues that anybody bothers to report about whatever your environment is that uses this issue tracking system. The most common ones are oriented toward software development. But Zendesk, for example, is oriented toward support calls. So if you're running a support organization, you probably have Zendesk, and but it does essentially the same thing, but with just that different orientation. And the point is that they all have the same general goal. This mouse behaves weirdly. They keep the information together, and they ensure that the problem stays in view until it's resolved. So you may have dozens of JIRA tickets or whatever issues or whatever it is, but by God, they're not going to go away until somebody says it's resolved and makes them go away. And while they're there, they contain everything that anybody wants to contribute about that problem, and all the discussions that happen can happen in your issue tracker. And so mostly we're talking about software problems, but if somebody fixes a bug or somebody adds a feature or whatever, something probably has to change in the documentation, and what happens is that they'll create a sub-issue that says document this, and by some process or other that'll get assigned to you. So you have a doc issue assigned to you. The workflow is pretty simple here: report an issue, people comment, blah, 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 until you get to step 4. And there to actually do step 4, to make the right changes and submit them for reviews and comments, you may have to navigate through that tracking system, and you may find all sorts of comments in there that are written by developers. They may assume a knowledge of program internals. The comments might not be easy to understand. Some of them are written by people whose main job is not writing prose. And on top of that, it may be hard to determine which parts of all of that stuff are relevant to the audience for your docs. So you have to learn to navigate those systems, and you have to learn to work with those developers to the point where you understand what you need to do in documenting. But really, you'll find if you work in a issue tracking system, as soon as someone raises an issue, lots of people have things to say about it, and they're kind of chaotic sometimes, and you may have to actually extract them and reorganize them and so forth before you actually can tell what people have said about the thing. But that's my experience. But What about you? Have you worked with issue tracking systems? I guess this is the main message I have here. The team you're working on with functions in an environment. And if you're uncomfortable in that environment, you'll have a harder time producing good docs. So understand the process. It's easy for writers to feel left out because the developers are really focused on development and development tools, and some of those are really not anything that you have to work with when you're a writer. And the process artifacts are, about how the software development is going mostly, and things like that. What's yet to be done, what's your burn rate, all of these other things, depending on whether you're agile or nobody does waterfall or nobody admits to doing waterfall, or yeah, or whatever you're doing. So you have to understand what the team really cares about, and be sensitive to that, and then you can work with them, and when you need their help, you can probably get it if you're if you understand what their issues are. So inhabit the communication spaces. Now this is interesting because different projects have different communication customs. Some may focus a lot on online chat or on wikis, or some may send email or other stuff, or they may use one for one thing and one for another, and there may be subtle differences between which they want to do where, and you need to learn those conventions when you're in Rome. Do as the Romans do, and so work with that. On the references slide yet to come, there's a link to Scott Birkin's book about how they did all this at Automatic. It's called The Year Without Pants, and I don't know if you guys know Scott Birkin. He's written a number of books in this general field, but he answered a challenge to go and lead a team at Automatic, which is the company behind WordPress. And they're a totally virtual company. They have actual offices, but nobody goes there. I mean, basically, that's it. And they have people all over the world working together, and periodically a team will decide they're going to have a meeting in Athens, and they'll all go to Athens for a week or something like that. So anyway, their communication methods were fairly archaic, things like IRC, or WordPress blogs, of course, and but they had conventions around it. So you always, if you wanted to communicate in a certain way, you knew exactly how to do it and what the effect would be, and that's what you need to do. Now, the last point I have here is about doc reviews, and this is a problem for a lot of writers, and I don't have a magic answer for it, but one thing you should do is make it efficient. So when the last thing you want to do is have developers think you're wasting their time and have them want to, go the other way when they see you coming. Okay, but you need reviews, and often you need them from developers. It's odd. You would think if your audience is developers, you certainly need reviews from developers. Now, in some situations, the developers are not even the right people to give you your reviews, because if you're writing end user documentation, maybe you need someone else to review your stuff, because the developers have very little idea usually of what end users need, or even what series of interactions they're using. But if you're in a situation where you're part of a development project and writing for developers, or at least for a highly technical audience, you need developers to review your stuff. And so tell them exactly what you need and what you don't need, and don't put too much pressure on them, but let them know if they're holding you up. And after that, it's a problem that I don't know if anybody has solved, but I don't know, what are your experiences with getting reviews? So here are some useful, I hope useful, references. The first three deal with version control systems, and they're basically official docs for these various things, or more or less official docs. The Git tutorials are from Atlassian, and they've done a nice set of Git tutorials. Although it doesn't matter how many Git tutorials you read, you'll still have problems trying to understand what's going on. But sooner or later, if you get into a project where people are using Git, you'll learn your narrow path through it and through the minefield, and you just won't step off it, and you'll be fine. The next three deal with issue tracking. There's a Wikipedia article on issue trackers. It's really exhaustive survey. I mean, they just go page after page after page of issue tracking systems. So if you're in the market for one, just go take a look at that. I haven't worked with Bugzilla, but I did look at that link, and that looks like it might be good docs. The link for Jira is also to Atlassian, because Atlassian makes Jira, and so on. And then Scott Birkin's book that I talked about, it's really an inspiration to those of us who don't want to live in a cubicle, because their company is totally virtual. And anybody else have references that you?
Can you enlighten us on the reference there to the year without pants?
That's Scott Birkin's book.
Yeah, I know.
Because he can work at home with no pants on?
Oh, is that the?
That's what I'm thinking.
You know, he addresses that in the book, but
the year in my bathroom.
It was no, I don't have any.
Bathrooms for winter.
The bathrooms for winter. Yeah. Okay. So anyway, if there are any questions, comments, corrections, there's my email address at the bottom, and thank you very much. All right. Well.